Welcome to my talk about lost in transaction. Glad you're here, and I'm also glad that I'm not the last talk between you and the party. So I hope you're still having some energy to concentrate on that. I want to talk about consistency in distributed systems. And I want to start with something probably you know or you don't know. I have no idea. I probably ask, who knows the domain-driven design book here? That's a couple, oh, that's a lot of hands, yeah. That were like 30, 40%. So that's a quite interesting book, actually. It's around for quite a while. But at the very end, actually, you have to skip a couple of chapters. The important things are at the end of the book. But there, Eric Evan defined a couple of things which are really interesting, which I wanted to start with. So if you want to store some data, for example, you have an entity, and today I do a lot of order fulfillment examples because they are normally easy to understand for everybody, but you can relate that to every domain you're working in. So let's assume you want to store some order. Then you have the order, and probably the order has a couple of line items connected to that. The first is the order that has a real identity, so you have an ID. You can ask for a specific order and these kind of things. That's called an entity. And the line items, they don't have a separate ID. It doesn't make sense to ask for a line item. You want to have the order with the line items. That's a value object. And then you probably have multiple of these entities. For example, you have a customer the order belongs to, and this has other value objects like the address, for example, right? So this is kind of common sense. That's what we do basically all the time. One important concept domain-driven design defines is a so-called aggregate. And an aggregate, it's kind of a boundary. I go into more details of that in a minute. And that sets a scope for certain things. One important thing here is if I have two different aggregates, they're not connected by, for example, by foreign keys in the database, right? So I want to have that loosely coupled. I come back to that in a second, as much as possible. So for example, I could say, hey, the order that has a customer ID attribute, but that's a string. I have no idea what that relates to. It's just a string, the customer ID, and the customer ID is defined somewhere else. So it's not a foreign key constraint. It's relatively loosely coupled. It would be easy to replace the customer service with something else if I want to do that, right? And then I can have other aggregates, for example. And now the interesting question, and that's actually what I want to dive into today most, is if I have two different aggregates, how can I do something which we do for ages easily, like do two activities in an all or nothing semantics, like either both succeed or not, right? All or nothing. That's what we know from transaction management. And how can we do that in this world, right? And that's more complicated than some people think of. That's about ACID transactions. Don't want to ask what ACID stands for. To be honest, I had to look it up myself when I prepared the talk for the first time. So A is for atomicity. So that means the all or nothing. Right? Either everything works or nothing of it. C is about consistency. So consistency means in the database, for example, is always consistent. That's about non-null constraint, foreign key constraint, these kind of things, what it can do in a database. The more interesting one actually is isolation. We want to talk about isolation in quite a bit. That basically means if you have two threads which all want to read the data, they're isolated from each other. So they don't see anything which is not yet fully committed. You need to know that from these isolation levels from databases like read committed, read uncommitted, these kind of things. Okay, that's isolation and durable. That's what a database should do. It should store the data durable, right? So these are ACID transactions, and they're around for quite a while. And the important thing is these kind of aggregates, these boundaries, they're considered to be a consistency boundary. I call that consistency boundary. Some people also say transaction boundary. But the important thing is you can do these kind of ACID transactions within one of these aggregates, like separately. But you cannot do a joint ACID transaction, right? So that relates to probably you're having a database here, you're having a database there, you cannot do a joint transaction on that. Right? There are different reasons why you want to do that. So first of all, you probably have different technologies, like different database providers. You probably have NoSQL here and Oracle over there. You don't care what's the implementation of the aggregate. You want to have an API where you say, hey, I want to store customers or read about customers and nothing else, right? So all the things you probably know from microservices are normally in there. So you want to have that as isolated, as autonomous as possible. Right? So this is the reason why we want to have these aggregates like separately. But the important thing to note here is that this is not kind of a God-given thing that you say, hey, I want to do, I have to separate like order and charge and customer in different aggregates. You can design these boundaries like consciously. So you could do, if you do a monolith, you have one big aggregate boundary maybe, and you store everything in an oracle, so you can just do transaction begin, transaction commit, transaction rollback kind of things, right? So that's probably a good thing to do. So you really have to think about these boundaries. But what I see happening at a lot of customers is that they do these kind of aggregates or different microservices, for example, but then they use a shared database. And they say, yeah, and we want to keep it that way because this, like, we now can do asset transactions. We can say, hey, we want to enter the charge, update the order, and then commit all or nothing. And that's quite a bad idea to do because now you have an implicit constraint here. You rely on the database transaction to be available. Whenever some of these microservices change to use a different technology, something will stop working probably, right? And you're not making that explicit. If you want to do this, you probably can, but then you have to make sure to make a really careful decision to make a big aggregate. Okay? For me, that's kind of the setting the scene. That makes sense so far? Okay, great. Now, there's something called two-phase commit. Who knows about two-phase commit, XA transaction? Wow, a lot of people. Who uses that? Who uses that? In production, we have 2. Who is happy? Oh, that's interesting. I have one who's happy, but it didn't have it in production. Probably that's a good coincidence. Okay, no, but that's actually what we see everywhere at the moment. So there's two-phase commit. The idea is that we have a transaction manager. I don't go into all the details how it works, but it basically is kind of a preparation phase. You ask everybody, hey, can you commit? They say yes, and then you let them commit, right? This way you get some confidence that it probably works when you commit. The problem with two-phase commit is that it's not a good idea to use. And if you don't believe me, there's a really good paper about that from Pat Held. And when he wrote it, he worked at Amazon. He now works at Salesforce. He worked also at Microsoft. He does a lot of papers on distributed systems. And he explains pretty well why distributed transactions are a bad idea. There are basically 2 reasons. So one is it doesn't scale. So if you build a bigger application, a bigger system, it's simply a bottleneck. It's simply a cause of deadlocks probably. So it's a limitation of your scale of the system. So that's one. And the other one, it's quite a complex technology, which is hard to operate, which is hard to understand. So most teams are not really getting that on the street successfully. So that's his own quote. So you probably better don't use distributed transactions. So I wouldn't have that in my toolbox at all. But that was something over the last 5 or 10 years, a lot of people had hey, yeah, I'm doing different databases, but I have two-phase commit. If you look at modern technologies, like for example, Apache Kafka or some of the NoSQL databases, they don't even support that, right? So there is no two-phase commit. There's a really good metaphor to remember that. I like that article very much. It's from Gregor Hopi. He wrote that in Enterprise Integration Patterns book. You probably know that. Was quite famous quite a while back. And he wrote that blog post about Starbucks does not use two-phase commit. So if you go to a local coffee shop, normally how it works is that I order coffee and then the person behind the counter normally, he or she just turns around, right? Making the coffee, get the money, get everything ready. And that resource is blocked exclusively for me, right? If I order 10 coffees, I have a queue behind me. They will hate me for that, right? Because they all have to wait. And Starbucks works very differently. I go there, I order. That's the person only takes the order and the money, right? And then I put in a queue. And then they have the baristas making the coffee, and they are scaled independently. And then I have the output queue, basically, and that's why they ask me for the name to have a correlation ID that I get the right coffee. Right. Sometimes in that process, there's a mistake. They make a mistake on the way, but then I'm waiting there and say, hello, where's my coffee? And then they just make it, right? So it's kind of scaling much better. I think it's a very good metaphor to keep in mind here. That's not new, actually. That's the interesting part. So there's a good presentation from Eric Pruer from the year 2000. So that's the year, 2000. So that's quite old, actually. But he said, okay, in order to build really performant and also resilient systems, we have to forfeit C and I, and that basically refers to consistency and isolation of that ACID protocol in order to build these kind of applications. That's fundamental. He already said that 2000. I think now, like 2019, we start to understand what that means and we start to embrace that, but it's actually quite old thinking. And he termed the term base, basically available soft state, eventual consistency. So he also coined the eventual consistency here. I don't hear that term too often, to be honest, but that's kind of the beginning of all that. And that basically means I have these two activities, A and B, I want to do them. I can do local ACID. I mean, if I talk to a relational database, for example, I can do ACID. So I can do transactions within these small boundaries, which might be the aggregates, which might be your Java program, your one Java program where you use whatever, Spring Boot for transaction management. It can be one resource, whatever that is. But it means like local ACID is possible. But I cannot do that on a global level. So if I do two things in a row, I'm temporarily inconsistent. So I do A first, then it's committed. And now somebody else can already see the consequence of that before I do B and before I know if everything succeeds. And that's what we're talking about. And funnily enough, that doesn't violate the consistency. It violates the isolation, right? A different thread can already see something, which goes again. The important thing, and one thing we now start to accept that this is a new normal. We cannot do like ACID transactions all over the place. We have to deal with it. And that's kind of at least new in terms of that we really embrace that, right? We are always normally temporarily at least inconsistent, but that doesn't matter, that shouldn't matter if we make it like consistent again at the very end. That's an important point. And we all know that. And whenever I discuss that with either business stakeholders or developers, normally what comes up is always the example of money transfer. Hey, I mean, money transfer, that must be like really consistent. We need transactions for that. Yes, we do need business transactions, but that's not ACID. I'm not sure when was the last time you transferred money? I mean, it's gone from my account, then it's somewhere, I have no idea where, and then probably it ends up in another account. But there's quite a time in between. If you do international money transfer, that can be a long time. And from what I see at a couple of banks I visited, I'm not sure even if they know where the money is in the meanwhile. So business transactions don't need technical transactions to work. That's an important thing. Pat Helen coined a different term for that. He said, we have to build applications that are ACID 2.0. At the time he wrote that paper, 2.0 was a good thing, right? Now it's probably ACID 4.0 or something like that. And he said, okay, applications have to be associative, commutative, idempotent, and distributed. Let me walk you through that. The first two we actually not really tackled today. So that's basically about ordering things. So if you're, for example, building a system which sends messages, right? It's probably a good idea not to rely on the order, on the sequence of the messages, because they might be out of order when they arrive at your service. And if you can handle that, you build a much more resilient application, a much more scalable system, right? So you should definitely think about these kind of things. I want to talk a bit more about the next thing. That's actually, I think, one of the key ingredients, one of the really most important things when building applications for like microservices, idempotency. That basically means you can do it twice without harming anything, right? So either you recognize that, or it just doesn't make any difference if you do it twice. So you can like process a message twice, you can do a REST call twice, whatever. I come back to that to quite some extent in a minute. And of course, distributed. I mean, distributed is unavoidable. We are building distributed systems all the time, and I think that's what's currently changing so much. So I love this metaphor for distributed systems. So this small hut, for example, that might be your Java program, right? There you have ACID transactions. There you're in one Spring Boot application, for example. There you're having a transaction manager. There you know what your threads are doing. It's quite cozy to be in there. But when you open the door, then you have that rough network and the rough ocean. And the rough ocean, that's the network. And networks work with probabilities, right? It's not guaranteed that the peer is available. It's probably there, but probably not. I mean, we're all used to Wi-Fi, and Wi-Fi in the trains is kind of, probably. And there are a lot of things that happen because of that. So there are the fallacies of distributed computing. You probably know them. So the first fallacy is the network is reliable. The network is not reliable, right? You should never count on that. And the more you distribute your application, the more these probabilities sum up. And if you build a largely complex system, it's hardly never completely available. And you should think about that, and you should care for that. Probably your application is not that big then. The problem is smaller, but it's still there. With the first REST call, it's there. And let's make that example. Let's make the example of a REST call. So you have let's assume you're building a payment service, right? Because you want to get some money for whatever service you provide. And then you want to offer credit card payments. And credit card handling you probably don't use yourself. You're using some service, something in the internet you can just leverage. And that's a REST API. And now you do that REST call, and you get a network exception, right? That's something you definitely should plan for. And one important thing to keep in mind here, normally what you do as a strategy is you have retries there. That's not too much about consistency, but it means I really have to think about idempotency. It's hard to avoid these kind of retries because if you have a network hiccup, you just want to retry it, right? So this is why the credit card charging, for example, has to be idempotent. If I make the example like what's the interface of the credit card service, if I, for example, just say, hey, here's a charge it, that's not idempotent because there's no way of really knowing that you have a duplicate call. But if you add something like a transaction ID, then it gets safe, right? And there's a big trend, and that makes a lot of sense actually in systems, to generate these kind of IDs as soon as possible. So for example, I know a couple of systems which generate an order ID already when you click the button, when you have no idea if the order will ever be placed or delivered, but you generate the order ID as soon as possible to recognize like duplicate calls, for example, or to build traces or these kind of things, okay? So that's really important. Give me a second. That's my favorite slide. I'm not sure about you. Took me a while. There was a vegan part in my life. I ate vegan for around 5 months, a couple of years back, before I had kids. Then I could do that. And my favorite dish is pasta, zucchini pasta. So there's a special slicer. You just cut the zucchini into the pasta, add some sauce, and that's a really good dish. I can totally recommend that. In the cookbook, they say, hey, that's even allowed for in the evenings. You can eat as much as we want to. You don't grow fat. You will sleep well. So it's a really good dish. And you can eat really as much as you want. Literally, they say that in the book. So when you eat your plate of zucchini and you forgot if you already ate it, you just eat another one. Or you eat another one, or you eat another one. So eating zucchini is totally idempotent. Eating pasta is not. Yeah, I know it's a totally silly example. It's the best metaphor I came up with so far. If you have better ideas, let me know. For me, the important thing is that it sticks, right? Because idempotency, what I see in a lot of products is because services, APIs are not idempotent, that causes a lot of effort, that causes a lot of trouble. So whenever you build a service, make sure the API from the beginning allows for idempotency. That's really important. That's really important. It will make the world a bit better. So, but going back to the distributed systems, there's another problem which we have to care about. So if, let's assume again, we are doing a REST call, we're getting a network exception, right? There's no way to know what just happened. So there are 3 possibilities, basically. So I did the REST call as a, I have to do it there, I think that works better, yeah. I did the REST call, but it never reached the service provider because the network was, whatever, broken, right? The second possibility is I reached the service provider, it started to work for me, but then it exploded. I have no idea if it committed its transaction or not. Or the third possibility, did everything totally correctly, committed everything, but the response got lost in the network, right? And you can make the same example with messaging, by the way. You send out a message, you never get a response, you have no idea what happened. Okay, and that's a thing. That's a problem, actually. Depending on the use case, you can probably ignore it, probably, but especially with payment, it's not a good idea, right? So let's assume I wanted to charge the credit card. I get an exception, And now I raise I cannot handle the payment. I cannot collect the money. So you raise an error, but you probably charge the credit card at that moment. You have to think about that. And the strategies might vary, and I go into more details in a second, but it might be that you just send out another message and say, hey, cancel that charge if you did that, or void it, or whatever the API can do here, right? So again, two things to note here. So the first is you have to think about that as a client. Whenever you do the call and you get an exception, it doesn't mean you haven't done it. And the second thing is, if you provide a service API, think about these cancellations. You have to offer these kind of methods for your clients. Okay, and next thing, because we're in distributed systems, what I said early on, it's about probability. So you never know when the system will be available or not. It might be later. In my experience, it makes a lot of sense to think about state handling in that case, to probably retry it not only for milliseconds, but for minutes or hours, especially for the constellation. And there's one thing, so if we take that example, like I do the charge, I probably retry it, and that's an external service. If they have an outage, I don't want to raise an error because I want to collect the money. I mean, that's good for the company, right? So I probably retry that for minutes. And if I cannot charge it, if I raise the error, I can make sure, even if that takes 4 hours, that it's not charged. And therefore, you have to keep state about that. And there's one thing I want to, let's say, make it transparent. So every human being has its bias. So what's my bias? That's my background. So I'm co-founder of Camunda. And we're an open source BPM or workflow automation vendor, basically. So we're doing an open source workflow engine. I worked with workflow engines with different open source projects over the last 15 years, basically. So all my professional life. Worked with a lot of customers in proof of concepts and these kind of things. So my bias is basically that I look towards problems through the lens of workflow engines and state machines, right? So that's basically my background, and that's important to keep in mind when I propose some of the next things probably. So for example, what I can do here is you could use this kind of technology like workflow engines in order to have the stateful things, right? Because in this case, I could say, hey, I want to do the payment. The only thing I have to do is charging the credit card, but I want to make that stateful. I want to be able to wait there for minutes in order to do that. I want to charge the credit card. If that doesn't work, I want to raise the payment failed. But then, and that's what I meant, now I want to clean up. I want to do the cancellation. But if the service was not available when I called it the first time, chances are high that it's not available when I do it the second time. So I want to wait in that activity until I really can do that, right? So again, that's kind of a state handling thing. And you don't have to do that yourself. So you can leverage these kind of technologies for that. If you're in DDD, that's kind of how DDD normally draws architecture. It's a so-called hexagonal architecture. But what I wanted to say with that slide is very easy. Basically, it says, if you use something like a workflow engine, that's kind of what you use as a library, as infrastructure. But, and that's the important thing, this logic I just described, like, hey, I do the retry for some minutes, and if that doesn't work, I give up. And if I give up, I still have to do the cancellation, and this might take longer, but it's important to do. That's business logic. And that's important. We get into more and more of these discussions, how to deal with these problems. The problem is a technical one. Networks are not reliable. It's a totally technical problem, but we have to discuss what's the right reaction to that with business stakeholders. And that's really important. So for me, that's totally domain knowledge. And you can either hard code that, then you also have to hard code around the state handling issue, which is kind of hard to do, basically, or you can leverage these kind of things. And what I wanted to do now, just briefly, to give you an idea how that works, I would show you a bit of code, because I'm a code guy. I want to see things to understand it. You could use different tools. I have a slide at the very end, so there are a couple of them in the market. What I use today is, by coincidence, the thing we do, which is Camunda, which is an open source engine. So all the code I show you is on GitHub, so you can just later on fork it, download it, or whatever, and just run it. What I have today is Spring Boot application. Who uses Spring Boot? just out of curiosity? Half of the people probably, okay, interesting. And what I do here, I provide a simple REST API, right? That's the example I showed you earlier on. And, oh yes, and to answer the most commonly asked question, yes, I use Eclipse. It's really the most common question. So I provide a REST API. I want to retrieve payment, right? Therefore, I offer, and that's the Spring way of doing it, Spring MVC, I just offer a method, I do a couple of nonsense things, but now we get to the real thing. I want to charge the credit card, right? And charging the credit card is my REST call. I could do that directly, but that's not what I want to do now. I want to show you how you can leverage something like a workflow engine for doing that, and in this case, I use what I said earlier on, Camunda. There's a Spring Boot starter you can use, so you just add a Maven dependency and then it like hooks up to the data source and transaction manager. So basically you add a Spring Boot starter, Maven dependency, and then it can do this. I just auto-wire it. And then it can define a workflow. And you can define workflows like graphically, and that's what most people do. But I prefer to start with a code way of defining them, because very often I saw that developers kind of afraid of graphical models because there might be something like hidden what they don't see. I totally understand that, so that's why I start with that. So I define a BPMN workflow. I come back to BPMN in a second. It starts here. What it does, it calls the service task, which I call Stripe here, because Stripe could be my credit card provider. And then I can attach code. And because I'm in Spring, I'm using a Spring bean here. So if I scroll down, I define that here. So that's my adapter. It's typical Spring bean. It implements an interface from us. There are multiple ways of doing that, but that's the easiest actually. And now I'm having normal Spring code in order to do my REST call. So I use the REST template. That's a normal Spring way of doing it. I might want to inject that from like the endpoint from a registry. I save that for the example. I create the request. I'm using the REST template to post it. I'm using Hystrix like a circuit breaker to safeguard that, and that's more or less it. And then I get a response back, and that's it, right? So the real REST call is relatively simple, and I just wrap it now in a workflow, which I said here, right? And why is that? What does it help? Now I can specify the behavior, what I made earlier on, like failed job, retry time cycle. So if something is wrong, I can retry it with a delay of, retry it 3 times with a delay of period time 10 seconds. This is how I can read that. And if there are no retries left, what I do something else, which is the Stripe cancellation. That's another Spring bean, which in my case only does this out, right? So relatively easy. And so on and so forth. So that's relatively simple. Then I can deploy that to my workflow engine. The workflow engine, by the way, did this versioning of that flow, because if I want to change the procedure, how I collect money, and I always have ongoing flows, it's not easy to change that. So that's why I version that model. And then if I do the charge, I just kick off a new workflow instance, right? I don't want to walk you through like the details of the engine. I just wanted to give you an idea of the complexity, what I mean with these kind of workflow engines, because that gets important when we look at the next patterns about consistency. And if I briefly show you that in action, what I have that one running, Spring Boot application, just started it up. What I have as well, what I call this fake server. So that's basically where I can send my credit card requests to, because I don't want to charge my credit card all the time. And I have a REST client. And what I can do is I can send a charge to this service, like that's a payment service, and that will call the Stripe fake service, which should actually work. It does. So what you can see is that it does like charge my credit card. And now what I can do, for example, and that's, I mean, play around with it yourself. You can adjust that service to behave slow. What I want to do here is to simulate a slow network, because that's what very often happens. The network is slow, and I have a lot of latency. And now if I do the same thing, I go via here. You see the exception from Hystrix in this case. So the circuit breaker said, hey, that's too long. I don't wait anymore. It called the Stripe fake. Took 30 seconds. That was too long for this guy, right? Now you see the retry happening and so on and so forth. And these kind of tools normally have kind of a UI that depends on the tool, how it looks like. But this is it for Camunda. And then you can see, for example, one is still waiting here. It still does the retry. So if I refresh that after a while, yeah, now it's gone because it's basically went that way. So you can also see that. You get a lot of these kind of statistics. You know where it is. And I love to use these kind of pictures because then people start to understand what a state machine, what a workflow engine is, basically. And yes, we have a lot of customers using that for really these kind of easy use cases. So that's what's the workflow engine. Like technology-wise, I have one Spring Boot application, having that as a library. That's the next important thing. It's not a very complex thing which runs somewhere centralized. It's a library, right, and can persist things. Okay. And then you can do things with that. And let's go through a couple of patterns. One thing which I think is very interesting, I came across that a couple of times. Let's assume you have a Rabbit like messaging, like RabbitMQ or ActiveMQ or whatever, like messaging. Then you have a service. At this customer, it was a Golang service, but it could be Java, right? It consumes the message, it receives it. It want to do some business logic in the database. That gets committed. And then you want to send a response message, hey, I did that. And you want to send some additional events because you want to notify certain other components that something happens. And the interesting part is, how can you do that? Like, again, in an all or nothing semantics. You don't have two-phase commit. You don't have distributed transactions available here. So how can you do that? And they even had a second requirement for that. They wanted to send the response as soon as possible. So this should be really quick because some client was waiting for it. What they did actually, and that's not that uncommon, there's a talk from an eBay guy doing the same thing. They used Debezium. Debezium is a framework from, I think, from Red Hat, which is normally used to replicate databases across data centers. And what Debezium does, it reads the database transaction log and can do things with it. So what it can do is you can leverage that, and whatever you write in the database gets committed, and then you leverage that commit in order to send the response and the additional events later on. That does work technically. The problem was it was quite hard to do. There were a lot of things they had to do it themselves in order to make that work, and you have to do that for every service. What at that customer, and that was a cloud CRM provider, we ended up with a simple workflow, basically, saying, hey, we received the message, we kick off a workflow instance. We have to do that idempotently, but that's doable. Then that's stored, that's safe. We acknowledge the message. Then we do the business logic, right? Again, probably you have to retry, but you can make sure whenever I did the business logic, at some point in time, I sent the response. I totally make sure that this is the case, and so on and so forth. That's a relatively simple use case, but it's about consistency, and these are a lot of problems you will get in these kind of microservice environments. And yes, you can do that at scale. I don't talk about that today, but I had that discussion, or have that regularly. It's like, hey, we're doing like REST requests, like whatever, 15K a second, 100K a second. Can you really do that with workflow technology? And yes, it's doable. You probably need other frameworks. If you're interested in that, approach me later on. So that's definitely doable. Going back to the content, there's a really good book. I can totally recommend that book. Martin Kleppmann wrote that last year. It's relatively thick, but it's totally worth it. About designing data-intensive applications. He writes about a lot of the patterns of these kind of distributed systems. And he also gives good talks. So if you're not into reading, what I can totally recommend is to watch his talk. I have one slide today from the Strange Loop talk. It was 2015, but it's still very, very up to date. And he had one slide there where he said, hey, if we don't have cross-service transactions, and that's what we said earlier, if we don't have two-phase commit, so if we don't have cross-service transaction, we only have basically two possibilities to deal with that. The first is compensating transactions. I talk about that in a second. Or apologies. And apologies, I don't talk about that much more today, but it's an important strategy, actually. Apologies means what you probably think it means. We don't stop inconsistencies from happening, but we detect them and then we act on it. It's like his example is like with Amazon or whatever, where you order something, they promise you to send it out in 24 hours because it's on stock. Then you order it. Probably there was something inconsistent, so it's not on stock. They send you an email, hey, sorry, cannot send it right away. Here's a voucher, whatever. Right. I want to talk about compensating transactions. And there's one classical example. Business-wise, it probably doesn't make too much sense, but everybody is using it, so I wanted to stick to that. And the idea is you want to book a trip, like traveling, a business trip or whatever. And in order to do that, the first thing you need is a hotel. You need like a rental car, probably, and you need a flight to where you want to go, right? So you want to book that like in that order. These might be different services from the internet, so you cannot roll it back. You cannot just say roll it back when something happens. For example, the flight cannot be booked, right? Then you already booked a rental car, you already booked a hotel. So what you do instead is, let's say, a rollback on the business level. You say, hey, I want to call some undo functionality, which really says, okay, in this case, I have to cancel the rental car and I have to cancel the hotel, right? Because I can roll it back, so I undo it. It's not a rollback in that sense. It also might cost money, so you probably have to pay some fee in order to cancel it. But at the very end, you're in a consistent state again. That's an important idea. If you search for that, that's very often known as the Saga Pattern. So if you're in the microservice community there, it's often referred to the Saga Pattern. And there are basically two ways of implementing that. And that's quite an interesting proxy discussion anyway. So even if you're not looking to Sagas, but you're probably looking into multiple microservices or services communicating, then you will have a lot of discussion nowadays about, do I orchestrate or do I choreograph? What's that? So I want to go through both, actually. So let's assume you want to go for a choreography, event-driven, for example. Then it could look like that. Hey, I want to book a trip. The trip says, oh, there was a trip requested. Event-driven means I push that event to a bus, for example, and I have no idea who listens to that. In this case, the hotel reservation service knows, oh, if there was a trip requested, the first thing I do, I book a hotel, and then I basically emit another event, hey, the hotel was booked. So the car rental service could say, oh yeah, then I have to book a car, then issue another event, the car was booked. The flight service knows, oh, then I have to book a flight, and so on and so forth, right? That's kind of the choreography way of doing it. It's kind of what I call an event chain, right? You will find that advocated very often, actually, but I come back to that in a second. In case of a failure, like the flight booking cannot be done, what happens is that in this case, that emits a different event, like, hey, the flight booking failed. The car knows, oh, if the flight booking failed, I have to undo, I have to cancel the booking I made, emit another event, the hotel listens to that, and so on and so forth, right? So this is kind of the cancellation part of the choreography. The thing is, I looked at a couple of projects, a couple of customers doing that in real life, and that's actually what's currently advocated in the, let's say, in the microservice world, in the event-driven architecture world. Then this is kind of the blueprint for the architectures because it's loosely coupled. And I always had a bad gut feeling about that. So it was always like, yeah, but how do I understand what's going on? I mean, this is emergent behavior. I throw in a coin and somehow everything gets done, but it's hard to understand how the system behaves. There's no place in your code where you can look at how it behaves later on. So I always had a really bad feeling about that. But then normally in the discussion, if I did that with customers, it was like, yeah, but I mean, there's no workflow engine here. Your tool is not on the slide. Of course you don't like that. So I always had this kind of like thing, but I mean, that's not the reason. And I was really, really happy when one blog post came up from Martin Fowler, and you probably know Martin Fowler. Yes, yeah, a couple of people nodding. I mean, he's a quite famous guy. He wrote a lot of things, for example, also about microservices. And he wrote that piece where he said, hey, the danger is that it's very easy to make nicely decoupled systems with event notification. I mean, that's a reason why we're doing that, without realizing that you're losing sight of a larger scale flow, and thus that yourself set yourself up for trouble in future years, right? So that's really exactly my gut feeling, expressed in words from a credible source. So I was really happy when I saw that. You find more. I mean, if you search the internet, you find a lot of these kind of things. Here, Dennis, for example, he wrote, if your transaction involves 2 to 4 steps, choreography might be a good fit. But if you have more, it gets confusing. it's hard to track. You get cyclic dependencies and so on and so forth. And there are more, like I could pull up a couple of more. Because over the last years, people really did it, and they hit these kind of problems. I can make a very easy example. If you want to change the sequence of things, and one thing about Sagas, which is also interesting, is that normally you order things in a, let's say, by risk or by cost. So in this case, it's natural to book the flight at the very end because it's the most expensive to cancel. Normally, you cannot easily cancel that for free. But it's normally easy to cancel a hotel. So that's why they do it first. So you could imagine that this changes like, hey, we're having a really good deal with that car rental agency. So we want to do that first. And if you just want to change something here, I don't want to walk you through it. You can do that as a homework. Try that in your head. You will end up with that. You have to adjust each and every service here in order to do that change. And not only that, you have to touch them. You have to redeploy them, probably not at the same time, but at least coordinated. You have to talk about that. You have to think about circulating trip bookings because they probably already like booked the hotel and now they change the order, so you have a versioning thing. So it's really, really not that easy to get that going, right? So the picture I choose for that is normally when you see choreographies in talks, like microservices talks, event-driven architecture, you see this kind of pictures, right? There are professional dancers. You don't need a central conductor, that's a bad thing, and they behave like with a beautiful dance. You can just add a new microservice, and it will just join that dance. And it's not exactly what I see at customers when I see these kind of architectures really in real life. It's simply hard to manage, it's hard to understand. So I definitely see a value in choreography, and I definitely see use cases for that, but it's not like the silver bullet again. So how would the orchestration example look like? So I could have the trip booking, and the trip booking now orchestrates other services to do something for them, right? So it says, hey, hotel, please book a hotel room for this trip. And then it waits for the result, for example. And then it knows, okay, and next I go to the car rental agency and wait for the result, and then I book the flight and wait for the result, right? And now you have that one place where you can control the sequence and where you can reason about the logic of your Saga, which for me actually makes a lot of sense actually in this scenario, right? Okay, good. So, yeah, and if you want to change it, that's easy now. I mean, you just go to the trip service, change the sequence. That's kind of easy. You get the versioning and so on and so forth. And if you use something like a workflow engine, which probably supports BPMN, and I talk about that in a second, then you can use the language there in order to implement that. So BPMN has something which is called compensation included. So this is like, whenever the reserved car was executed successfully and I roll it back on a business level, I trigger that. Then I already configure which compensation, which undo activity should be executed whenever I do that, right? And that's already defined in the model for all of the activities. And then it's easy to implement these kind of Sagas with, for example, a BPMN workflow engine. Okay? Okay, see nodding people, that's a good thing. Good. So that would be like Saga pattern implemented with BPMN. Not the only way of doing it, but I think it's a very, very useful way of doing that. One important thing from my perspective to keep in mind here is that this kind of logic, the Saga logic, the Saga pattern logic, is part of that trip microservice. So if you remember what I did with the Spring Boot application earlier on, then I said I added a Maven dependency. So that means I use this kind of workflow engine as a library within the service. So it's kind of an implementation detail of the service. A lot of people, when I say workflow engine, they think of you having something central somewhere. You have to operate that, and then you deploy there. It's a complex thing. And no, it's a library. You can really run that in your service. If you have multiple microservices, they might have their own logic where they deal about long-running things, about consistency, whatever. For example, for charging the credit card, for what we had earlier as an example. And then this logic will be part of that microservice, right? So that's nothing central. So it's really distributed and just implementation detail. And Yeah, right. Good. If you want to learn more about Sagas, one of the, I would say the best sources at the moment is from Katie McCaffrey. She was worked at Twitter when she did that. She now works for Microsoft, and she has a talk at Java on the Beach from 16, 17. But you will find that on Twitter, on YouTube, and she explains very well also how a Saga probably should be laid out. So if you want to learn more, I think that's a good recommendation. So I want to briefly touch base on graphical models, because I talked about that earlier on. And what I see is that normally developers, that's why I didn't start with it, if I show graphical models, it's like, oh no, we were there like 10 years ago, it didn't work. Model-driven architecture, all these kind of things, we don't like graphical models. And then I normally, when I talk about Sagas, I pull up this example. Because, and that's from Clement Fusters, he works at Microsoft. He's a great guy, so it's nothing about Clement. And it's a quite old blog post, that's also important to say probably. But he wrote about Sagas, and the beauty of that example is he did the same example, right? So that's exactly what you already know from what I explained earlier on. And in that blog post, he explains how he implemented that. And he, by the way, he used there a more choreographed approach of doing that, there's even a kind of a routing slip pattern, which is a third I skipped that for today. But if you want to learn about that, there's a blog post. But the important thing is, he basically described what he did like all over the place. But what he started with, obviously, is the picture. I mean, of course, because then we understand what's going on, what we intend to do. And I think it's important to value these kind of pictures. And in this case, I mean, he works at Microsoft, so I guess it's probably PowerPoint. It's dead when you upload it to the blog. It's probably outdated when the first guy reads the blog, right? So what BPMN is about, and that's, first of all, it's an ISO standard, that's interesting, so it's adopted worldwide. It's nothing invented by whatever. It's really a big thing at the moment. It's the best language, I think, for these kind of requirements. And it's what I call living documentation, or what also other people call living documentation. So it's not a dead picture, it's code. It can be visualized in a very good way. And what I said earlier on, all these requirements about consistency and other problems in distributed systems, you have to discuss them with a lot of people. So it makes sense to have that visual, right? And don't have the mess. You can, for example, visualize like this is from test case. So I know that this test scenario exactly walked this path, for example. Or you can leverage it, what I call best DevOps. So the whole operations of the system. I think that's for me, that's one of the most important points. So if you have a system does a lot of calls in between or messages or whatever, it's sometimes hard to understand if something breaks, why it broke, what's the data, how did it get there, how do I get it out of here? And these kind of tools, they provide you with a good overview where you can see, hey, there are instances stuck, like I exactly see where they are stuck. I can look into the context. I can probably fix it. I can restart things and so on and so forth. And then you even get a lot of like statistical data. So I think that's really, really valuable. But I'm probably a bit biased here. If you don't like that, what I still can do, I started with code, right? You can do that as well. We have customers doing things like that, building their own DSL in order to really code the Saga logic. And what's happening in the background, it generates a model. And if we generate a model by code, for example, for Camunda at least, other tools might do the same, we generate the picture as well. So we auto-generate with an auto-layout this kind of picture. So you can use the code, why not? So if you find that interesting, and I personally find that totally interesting, so I think there are a lot of use cases for these kind of state machines. Then you will probably do an evaluation. You will probably look at the market and say, hey, okay, workflow engines, that could be something. And then you will face that. And I find that amazing at the moment. There are a lot of things going on, but it's quite hard probably to do a proper evaluation. So I categorize the tools I would see as valuable in this field basically into these buckets. There is still something I call pure play BPM vendors. Very often like advertises low code tools like get rid of your developers. Business can click everything together. Obviously that doesn't work. So that's the bucket you should stay away from. Then I even added a couple of tools here as examples. Only examples, there are more. And that's interesting actually, if you're looking at a lot of the, let's say, big, in this case, all Silicon Valley companies, but basically companies that do frameworks because they need them, right? Then you see that they all started to do something around workflow engines. Uber did Cadence, Netflix did Conductor, Airbnb did Apache Airflow, ING did Baker. So there are a lot of these kind of frameworks evolving. They're normally very biased toward their world, so it's hard to adopt them probably in your environment. But it clearly shows the need for these kind of things. Then there are open source workflow engines. That's normally the pool where you can choose from easily, especially in the Java space. There are quite a lot of them. There are cloud offerings. If you're going cloud, basically all of them have something like AWS has step functions, Azure has durable functions, Google has Google Cloud Composer, and so on and so forth. Basically all of them have something. And that's probably the more interesting part to separate or to draw a line. If you look at other frameworks like integration frameworks, Apache Camel, and so on and so forth, they normally lack the state handling, so that's probably not that interesting for what I talked about today. Or very often you also have to compare to these, what I call data pipelines, like Spring Data Flow and so on and so forth. Okay, so that's quite a hard market. If you want to evaluate what I would ask myself or what I normally tell people to ask themselves, does it support stateful things, right? So it has to keep state. The necessary flow logic, like compensation and these kind of things, that's important. And is it visible? So what I see, for example, if you look at Netflix or Uber, they reinvented a new language. The language is not really powerful. I can already foresee the problems they run into because we ran into that like 10 years ago when we built something like BPMN. And it's not really visible. So I think that's pretty powerful. So that's, for me, the most important thing. Go for BPMN and then select the language. And does it scale? That depends on what you want to do. Like, do you need scale or not? Right? So these are typical the questions. If you want to have a very quick, unbiased, totally unbiased pro tip from me, that's very easy. What do you want to do? But evaluate yourself. I mean, that makes a lot of sense. So let's do a quick recap. We started with the aggregates. So aggregates are consistency boundaries. And even if you're not in DDD, don't use the term aggregate. You probably do microservices or services. So every Java application is its own consistency boundary. That's important. Don't use distributed transactions. That's what nobody really is doing, and you shouldn't start doing it. But that means you have to get into the world of the eventual consistency. You have to think about the problems you will get. You have to think about solutions, how to get out of there. And that normally means also that a lot of people have to get familiar with it. Also on the business side, on the developer side. So that's not an easy thing to do. But what I really like about like this year, last year, is that people start to get aware of this fact. Idempotency is super important. Never forget about the zucchini noodles. And some consistency challenges require state handling because you want to wait for things. You have the network, you don't know if it's available now, so you have to care about that. So it's kind of a state handling. There are different strategies. One thing could be Saga and compensation. I think that's good to have in mind. That's all I have. Thank you so much.
Thanks so much for your amazing talk. I guess I'm not the first one who asked this question. Why do you use Eclipse?
So as I already answered the question about Eclipse, why? Actually, I have different IDEs on the machine, and Eclipse normally poses that reaction, so I like keep doing that. A colleague actually uses Opera because that's normally like everybody says, "Whoa, what's that?" No, I don't care. I could use different ones,
okay.
But Eclipse is fine for me.
Okay, thank you.
There's a question like there in front. That's what I see here. He's on his way, yeah.
Hello, thank you for your presentation, but I have a little question. In the start of your presentation, you told about that the engine could process, for example, 50K requests.
Yeah.
But what is under the hood? So how it should
How can it do that? Like
yes,
the performance,
yes. It's very interesting.
So there are different types of engines. So what I looked at in the demo was the Camona engine, basically. The Camona engine works like we're having a relational database underneath to store things. With a relational database, it depends very much on the database itself, how much you can do. Normally, 50K per second, it's quite too much for most of the databases. So what we have as a separate project, its own open source project, it's called cb.io. And there we do a workflow engine from the ground up differently. And it basically works, I wouldn't really say event source, but it's kind of, we're having an event stream, and we're having stream processors working on that. We're building an own distributed system with Raft protocol and these kind of things. So it's pretty much comparable to what Kafka is doing or Cassandra is doing in terms of getting the scalability. And with that architecture, we are able to scale it horizontally. And that means we, depending on the instances per second you need, you might have to add nodes, but you can definitely get to where you need to get. And with that architecture, we are able to run even like 100K or 1 million instances per second. And that works quite reliable. Do we have more questions? There's one. Probably.
Давайте тут поближе, потом к вам.
Okay. Sorry. Skip that.
Hi, my name is Sergey. Thank you for your talk. My question is about that approach you talked about. I mean, stateful retry and cleanup. I understand that in case we in case of n tries and success, we have eventual consistency. In case of stateful retry and some cleanup, in some cleanups and cleanups is successful, we have eventual consistency.
Yeah.
But what if all that operations fails?
Yeah. So let's go back to that example. So it's basically that example. And the question was, I rephrase it and you tell me if I got it right. The question is, okay, what if this fails as well, right? So the thing is, that can happen, it's a possibility, and I wouldn't plan for it, so I wouldn't model that anymore. But what it can do, if you have that tool, like if you have a workflow engine here, what happens is that it basically gets stuck here, and it creates, we call that an incident. And that basically means it bubbles up in the monitoring. So some operator sees, hey, there are incidents, he can look for, so that's kind of like a red exclamation mark on the model. He can look into that, he can probably fix it manually, in a batch or not. But I would definitely stop there. I would say, hey, this is like the 99% cases or whatever, I get through that model. And if that fails, I have to clean it up manually. And then I have to make sure that it bubbles up and that I understand what happens. Which is easy in that scenario. That's what I call that BizDevOps. If you're in a dead letter queue, if you're in a log file, it gets harder to do. But at some point in time, you have to get a human on it. Otherwise, it's too hard to do. Yeah? There's one question? Yeah.
Yes. You showed some code for community engine.
I don't really get that. Try it again.
Okay.
Yeah.
You showed some code for community engine, and there were synchronous actions tied together. Is there a sync API for community?
Sorry, I didn't completely get it.
Asynchronous API.
Asynchronous APIs. So the question is,
community engine, exactly. Yes.
So what if this is not like a synchronous REST call, but an asynchronous, like messages, send a response, or?
Well, no, I meant like if I use completable futures in Java or something like that.
Yeah. Okay. So normally, no, I wouldn't. Actually, in this case, I would stay with a where is it? With synchronous code here, because I want to let the workflow engine know what happens here. And the interesting part is like this code now is hooked up to the workflow engine. And what the workflow engine can do, it has its own thread pool. So it's not that you're blocking like the request, for example. So you're not blocking the REST request starting the workflow instance here. So using their own threads from the workflow engine. And that's why I wouldn't do that asynchronously, because I want to get the result. But there are a couple of ways of doing that, which probably if you, like we're having that discussion zone or still there the whole evening. So if you approach me, I can show you a different way of coding that, which might be more fit than if you're looking into the asynchronous world. So there are a couple of ways of doing that. I'm not sure how much time we have left.
Unfortunately, we're out of time, so we can continue in discussion zone. Thank you so much, Bernd Rücker from Kommune.